Variation is of the form y equals kx. And what it implies is that there's a constant rate of change. And it's a direct variation so that if k increases, y increases. If k decreases, y decreases. They're directly related to each other. And it'll be the same thing if x increases, y will increase, and if x decreases, y will decrease. Those are also directly related to each other. The constant of variation, it's also called a constant of proportionality, is k. And this is the rate of change. So that's how fast it's changing. Okay, to find the constant of variation for each, we just look at the number that will be where k is. So my constant of variation, and this one is -4. And in this example, my constant of variation is going to be 1/2. To find the slope, we can use our equation, use our 2 points. And I'm going to do 0 minus 4 over 0 minus -1. And I'll get -4 over +1, which is also -4. Notice anything? Your slope and your constant of variation are going to be the same thing. So y equals kx is the exact same thing as y equals mx. So if I know k is 1/2, what do I know about m? Because k and m are equal. To graph a direct variation, okay, every direct variation, okay, if it's of the form y equals kx or y equals mx, goes through the point 0, 0. Okay, so step 1 is going to be put a dot at 0, 0. Okay, we're doing this one, y equals -6x, I put a dot at 0, 0. Step 2 is going to be find your slope, which is k. And we're going to use that as directions. Okay? So in our case, slope is -6, but that's the same thing as -6 over 1. So if I have a whole number, I'm going to put it over 1. Right? Slope is the y2 minus y1, x2 minus x2, but slope is also rise over run. And this tells me whether or not to go up or down. That's the rise, and this tells me to move to the right. If m is positive, you're going to move up the number of spaces in the denominator. And if it's negative, you're going to move down. Not the denominator, I'm sorry, numerator. I meant numerator. And then after you've moved up or down, then you move right the number of spaces in the denominator. Okay, so our slope here was -6, which is -6 over 1. This negative tells me I'm going to go down 6, and then I'm going to go over 1. So from 0, 0, that's my starting point. I'm going to go down 1, 2, 3, 4, 5, 6. So down 6, and then over 1. And that's where I'm going to put my next dot. And then I connect the dots. Basically, actually connect them. Any questions on that? Wesley, any questions? Oh my gosh, I'm seeing direct variation. Okay. Anytime you see this phrase, y varies directly as x, this right here tells me I'm going to be using this. Okay. So what I want to do is I'm going to use y equals kx. I'm going to plug in y and x and solve for k. And then I'll use k to make an equation. Right. So what I have is y equals kx. They give me y and x. So plug those in. So y 72 is equal to k times 8. So I'm going to divide both sides by 8. And k is going to be 9. So my equation is going to be y is equal to 9x. This is the equation of the direct variation. So then I'm going to take this equation, and it says find x when y equals 63. So I know that y is equal to 9 times x. So if y is 63, that's still 9 times x. So I'm going to divide both sides by 9. And x will be 7. And what this is basically telling me is there's this line that exists somewhere in the universe that has the point 763 on it and the point 876 72, as well as an infinite number of other points, but every single x, like if I did 10, let's say, then y would be 90. Or if I did 2, then y would be 18. So every single y is going to be twice as much as, or 9 times as much as the x. All along this whole line, to infinity and back, and negative infinity and everywhere. This is the most common direct variation ever. So if we have the distance a jet travels varies directly as the number of hours it flies. That's distance is rate times time, where r is kind of substituting in for our k. T is acting like our x and D is acting like our y. But it's the same steps, just different letters. So if it travels 3,420 miles in 6 hours, we want to find out how, write a direct variation equation relating distance and time. So if distance is equal to rate times time, then 3,420 miles is equal to some rate times 6 hours. And I'm going to divide by 6. Okay, so what we get is distance is equal to 570 times time. Because this is our k, 570 basically. Now, we're asked to graph this equation. Obviously, I do not have 570 lines right here. So I'm going to have to make some adjustments. First of all, distance and time are always positive. Until, of course, they invent time machines, in which case time might be negative. But for right now, it's always positive. So I don't need any of the negatives, so I can put the lines right on the very edge of the graph. And then I need to make a scale. This will be my hours. So maybe I do every 2 lines is an hour. Well, obviously, if I did every 2, it wouldn't work for, I need to get up past 570, because this is my my miles. So if I do 50, 100, 150, 200, 250, 300, 350, 400, 450, 500, 650, 700. So each one of these is 50. It's a direct variation, so it always goes through 0, 0. So my first point is going to be on 0, 0. My slope is 570 over 1. So I'm going to have to go up 570 and over 1. Well, 500 is right here. Oops, sorry, that's 600, not 700. Okay, 500 is right here. This is 500. This is 550. So 570 is probably going to be about halfway between those two. And then over 1. So it's going to be about there. And then I connect my dots. So that's the graph of this distance equals rate times time direct variation for airplanes. To estimate how many hours it will take for the plants to fly 6,500. Okay, there's no such thing as a plants. Well, maybe there is, but they don't fly. For the plane to fly 6,500 miles, I'm going to use that same equation. For distance, I'm going to put the 6,500. And I'm going to divide both sides by 570. I'm not in the right mode anymore. Okay, so it will take us 11.4 hours in this particular airplane to go 6,500 miles. So a sequence is a set of numbers that are in a specific order. They have to go in the set order, and they generally follow a pattern that can be found. For example, you add the same thing each time, you multiply the same thing each time, you subtract the same number each time, you divide by the same number each time. In a Fibonacci sequence, each new number is the two before it added together. So, but there's a pattern. You know, maybe the pattern is multiply by 2 and then add 1. Who knows? But there's a pattern. The terms of the sequence are just the numbers in the set or in the series. Okay, an arithmetic sequence is a sequence in which all of the numbers have the same difference between them. So as you go down the series of numbers down the list, the same number was added every time or the same number was subtracted every time. And the common difference is that number that you were adding or subtracting. So an example of an arithmetic sequence would be maybe and then it'll keep going. And what I'm doing each time is I'm adding 3. Forever and ever and ever. So that would be my common difference, which is D, would be 3. Or, you know, I can subtract the same number every time. To get from a 3 to a -1, I'm subtracting 4, subtracting 4, subtracting 4, etc. So in that case, my D is then -4. So if I'm adding, D is positive. If I'm subtracting, D is negative. What I do is I check the difference between the numbers. So what would I do to turn a -4 to a -2? I would add 2. To turn a -2 to a 0, I would add 2. To turn a 0 to a 2, I would add 2. And I check every number that's given. As long as these all match, then this is an arithmetic sequence. Now what happens in this situation? I have all these fractions and I need to check, am I adding or subtracting the same thing each time? So the first thing I need to do is find my common denominator. Which in this case is going to be 16. So I'm going to give each of these a denominator of 16. So to give 1/2 a denominator of 16, I'm going to multiply by 8. So it's going to give me 8/16. To give 5/8 a denominator of 16, I'm going to multiply by 2. So it's going to give me 10/16. To give 3/4 a denominator of 16, I would multiply by 4. And that's going to give me 12/16. Excuse me. So rewritten, I'm going to have 8/16, 10/16, 12/16, and then 13/16. So each time here I'm adding 2/16. Here I'm adding 2/16, and then here I add 1/16. This doesn't match, so this is not arithmetic. In order to be arithmetic, they all have to match. Nine. So to turn a 15 into a 9, I'm going to subtract 6. And then I'm just 9 to 3, I subtract 6. I subtract 6. So I'm going to take that negative 3 and I'm going to subtract 6 from it. And I'm going to get my next term. Negative 9. So if I were going to rewrite the series and include my new term, it would now have a negative 9. And if I wanted to find the next one, I would subtract 6 from that, and I would get negative 15. Subtract 6 from that, I'd get negative 21, and so on, forever. But really, we just needed to find the next term, negative 9. To turn 9.5 into 11, we're going to add 1.5. To turn 11 into 12.5, I'm adding 1.5, adding 1.5. So then I take 14 and I add 1.5 to it, and I get my next term, which is 15.5. Which I could then add 1.5 to it. I could get as many terms as I wanted, right? I just keep adding 1.5. There's a formula to find a certain term in the sequence. So if you want to find the 25th term, you can use this formula. If you want to find the 900th term in the sequence, you can use this formula. Okay, and a to the n, the little subscript n just means the number of the term you want. Not the value, but just like the number, the order it is. Is equal to a sub 1. A sub 1 is the first term in the sequence. Okay. And that is plus d times n minus 1. Okay, obviously d is the common difference, and n is again the number of the term you want. Right. So first we need to find, if we're going to write an equation to find the nth term, not the nth term, just the nth term, we need to find our common difference. So to turn a 12 into a negative 8, and then a negative 8 into a negative 4, and then a negative 4 into a 0, I'm going to add 4. So this is D. So a sub n is equal to a sub 1, which is negative 12, plus 4, which is d, times n minus 1. So again, this is the first term, and this is the common difference. Now to use that to find the 9th term, that means n is going to be 9 in this case. So the 9th term is going to be negative 12 plus 4 times 9 minus 1. So I take that n and replace it with a 9. So we get negative 12 plus 4 times 8. So it's negative 12 plus 32. So it's 20. So if we kept going and added 4, and we did that 5 more times to get to the 9th one in a row, it would be 20. That's the number we should have. And like, you could add 4 or 5 more times and that wouldn't be that big a deal. Let's find the 45th term, though. You're not going to want to do that, add 4 all those times. So we're going to take a to the 45th, or yeah, the 45th term, and take negative 12 plus 4 times 45 minus 1. So that's 4 times 44, which is negative 12 plus 176, which is going to be 164. Proportional relationship. That's the same thing as direct variation. It's going to be y equals kx or y equals mx. It's going to pass through 0, 0. And if you take all the x's, all the ordered pairs, right, and you put them as a fraction x over y of all of the possible ordered pairs, they'll all be equal to each other, because you can all reduce them down to the base. And that's how you know it's proportional, because 2 fractions that are equal form proportions, right? So we're going to have a bunch of fractions that are all equal, so it's very proportional. All right, how do we write a proportional equation? All right, first we need to also determine if it is proportional, but how do we do it? Okay, Marcos is a professional trainer at the gym. In addition to his salary, he gets a bonus for each client he sees. Here's his number of clients. Here's his bonus. That's going to be my x and that's going to be my y, because my bonus depends on the number of clients. And y always depends on x. So first I'm going to look and say, okay, what am I doing here? I'm adding 1 each time. Okay. And here I'm adding 45 each time. And what this kind of implies to me, okay, if y equals kx, doesn't k equal y divided by x? So if this is a proportional relationship, it's going to be 45 over 1, which is going to be 45. First I need to see if it is proportional. So do you remember how I said right here, all the ratios will be equal? So I'm going to check 1 over 45. Is that equal to 2 over 90? Is that equal to 3 over 135? Is that equal to 4 over 180? Is that equal to 225? Well, 2 over 90 will reduce to 1 over 45. So yes, those are equal. And 3 over 135, if I divide both of them by 3. Here, if I divide both of these by 4. And here, if I divide both by 5. So all of my ratios are equal, so it is a proportion, or proportional relationship. Okay. So since it is proportional, I know it's going to be y equals kx. I'm pretty sure k is going to be 45, so I'm going to get y equals 45x. And I'm just going to check it. That works, right? If I put in 1, I get 45. If I put in 2, I get 90. It works. It's perfect. We've checked it. It passed. Ooh. Okay, so we're going to use this equation to predict the amount of his bonus if he sees 8 clients, right? I don't want to use red. So y is 45x. X is the number of clients. So if we plug in 8 clients, of $360. Still linear a lot of times, but not in a direct proportion, so not proportional. So y equals kx is not what we're going to use. Okay. Instead, what we have is the ratios are not equal. So our formula is going to be y equals mx plus b, or y equals kx plus b. We're going to have to add or subtract something onto the end after we multiply to make it work. Okay. So again, our first steps are going to be kind of the same. I'm looking at this and I'm saying, oh, okay, there's a difference of 1 each time. And here, there's 3 each time. Actually, why don't we change that m to a k, just for now. This is going to imply that k is going to be 3 over 1, or 3. But 1 over 9 does not equal 2 over 12, because 2 over 12 is 1/6. If I reduce it, it also doesn't equal 3 over 15, because if I reduce that, I get 1/5. So this is not proportional. So what I need to do is I need to find b. In order to do that, I'm going to take my 1, I'm going to multiply it by my k, and I need it to equal 9. I'm going to take my 2, and I'm going to multiply it by k, and I need 12. So I'm looking for something that if I take these numbers for x and I multiply them by the 3 for the k, what do I add to get 9, 12, 15, etc.? So 1 times 3 is 3 plus what equals 9? 6. Right? 3 plus 6 is 9. And then I check this one. 2 times 3 is 6 plus 6 equals 12. 3 times 3 is 9 plus 6 equals 15. They're all the same, so this tells me this is my b. So k is 3 and b is 6. So again, we need to find the difference here. I'm adding 1 each time on my x's, but on my y's, I'm subtracting 1. So my k looks like it's going to be negative 1 over 1, or just negative 1. But obviously this doesn't equal anything, it's undefined, but none of these are in proportion to each other, so it's not proportional. So what I'm trying to find, as you know, we've got y equals kx plus b. Maybe if we wrote it this way it might be easier. Okay, I'm trying to find the numbers to fill in here. Okay, so I've got my k as negative 1. These are my x's, 1, 2, 3, and 4. Here are my y's. So negative 1 times 1 is 1, plus what equals 3? So negative 1 plus 4. Right, because it's negative 1 plus 4. Here I have negative 2 plus 4 equals 2. Negative 3 plus 4 equals 1. Negative 1 plus 4 equals 0. Or sorry, negative 4 plus 4 equals 0. So, oops, I'm putting zeros in when I meant to put 4s. So this is my b. So I plug in my k, and I plug in my b, and I have my equation. So y equals negative x plus 4.